Hey, a little about me. I'm a student at the University of Waterloo, and I'm trying to get a job. Computer science is probably not the best field right now because AI is taking over the whole field. Um, but I still have to do my due diligence and learn because when AI does get taken over, I'm hoping knowing something like algorithms and data structures will help me um, prompt AI better in the future. Um, Here we have NeetCode 150. I am trying to get a very good job at a fake company and squeeze by before AI takes over. Here you can see I've solved 63 um, problems. This is literally because I got an interview around March area. I did it for 4 weeks straight, and I got to 63 problems. Did I understand much? No. So my goal right now is to create a video of me solving a solution for NeetCode 150 and sort of going through my process without using AI, hopefully without using AI, and sort of understanding how to solve each problem and kind of motivating myself to do so every day. And I literally got this inspiration from the guy that made NeetCode, which was NeetCode on YouTube. Anyway, moving on. Let's do a problem. I'm probably going to start with a small problem right now. Let's do a arrays and hashing problem. We can actually work. I'm going to work my way from arrays and hashing to graphs again by doing one problem every day. So this contains duplicate. I've kind of already seen the answer. So I'm going to do arrays. I'm going to do contains duplicate, and I'm also going to do valid anagram and twosum because they're easy problems, and I've already kind of done them a lot of times. So I'm just going to count that as just one problem today. So the solution here is just returning the len of nums at I. Sorry, not nums at I. Nums does not equal len of set of nums. Basically, if the length of the duplicate array does not equal the length of a set of the duplicate arrays, then we output true. Well, alright, so okay, I suck at explaining, so this is another reason why I want to do this. For example, length of nums. If we have 1, 2, 3, 3, that is nums, the nums array. But in a set, it gets rid of all the duplicates. This is how semantics go. So we would have a set that is 1, 2, and 3. Right? So then the length of this array would be 4. The length of this array would be 3. Thus, 4 does not equal 3, so it returns false. But here, we see that we want to return true. Oh wait, this returns true actually, because 4 does not equal 3 is true. So we want to return true, so we know that this contains a duplicate, and this doesn't contain a duplicate. So the basic algorithm is that if one doesn't contain a duplicate in the set, if one side contains a duplicate and the other side does not contain a duplicate, the lengths will not be the same. So 4 does not equal 3, thus it is true. the statement will be true, and then we can return true this way. So if you run, you can see that works. I hope that made sense. I know I'm kind of working on my sort of way of explaining better, so I don't know if that made sense or not. But let's move on to anagram. Anagram. Maybe we'll do 2 questions today, because I'm learning how to explain my thought process. So the next question is anagram. I saw this a while back, so I don't really remember a lot of the time, but I do know the sort of way to do it, like a general algorithm. To do so, I need to create 2 hash maps. So hash map 1 equals default dict, which is a library that helps create hash maps. So 2 equals default dict int. So my idea here would be to populate one hash map with all the values of in a string. So it's saying an anagram is a string that contains the exact same characters as another string. The order of the characters can be different. So if you take each literal char and place it in a hash map and count how much a single char occurs, and we do that to the same the other string, and we come to find out that each char in each hash map has the same occurrence, then it would be an anagram. But for base case, instead of going through this whole process, what we can do is check if the len of s and t are equal. And if it doesn't, we can actually return false, because then we know it's not an anagram, because if one length is less, then surely, if this r was in here, surely there isn't the same amount of characters, since one length is less. Right, so moving on. So first we have to populate hash, and to do so we want to go and iterate through the s string. So here would be race car. So we would do for c in s, we would populate the hash map 1. So hash map 1, and here our key will be the char. So char in this iteration would be r. So we would put c in here, and we can do plus equals 1. So if you're going to see this in, if you're trying to see race car in a hash map, we would see it as so the first iteration would be r, so hash map at r would be equal to 1. And then hash map at a would be equal to 1. Hash map at c would be equal to 1. Hash map at e, I'm going to go up to c here, about e would be equal to 1. And hash map at c, now we're at race car, so c, then change to 2, so it added 1 to the already existing key c. And it would go on until we end the string. So if you continue here, we will do the same thing for t. And the same sort of occurrence happens in t. So now we have everything populated, and right now we're containing it in on because we're running this n times, so we're running it n times worse time complexity. And here we can then go through our hash map. So for key in hash map 1, so here we would want to check if it doesn't exist. If the occurrences aren't the same, then we would return false immediately. So if hash map 1 key does not equal hash map 2 key, then we return false. And if we could go through this whole iteration without returning false, then we would know that it's true. And why is that? Because we would know that every single char in hash map 1, which is S, would have the same quantity in hash map 2. And we know this because we know that this would end for both cases because we check the lengths of S and T, and if they're not equal, then we know that it's false already. So we have every case covered here, and I think this should run. Nope. Right, so we forgot to put 2 here. Right, so it runs. There we have it. All of it accepted. So here, we're going back. If I didn't explain it properly, I'm going to explain it here. Key here would be R. So let's say R is the first key. It checks if R, if hash map R, which is going to be returned as 2 because we can see there's 2 iterative occurrences of R, 1, 2, does not equal hash map 2 R, which is also 2, then return false. But since they do equal, go to the next key, which is A. So if A, hash map 1A does not equal hash map 2A, then return false. So let's check. A and A. So there's 2 occurrences of A. There's 1, 2 occurrences of A and T. So if we don't return false, we go to the next character. So we do it for C. And so on. And we then check every case. It's the same thing for here. We check J, J's right, A is right, R and M not right. So then we return false because it's a non-existent. Right, so that's basically it. I hope you understood my explanation, and hopefully going to do another one tomorrow. Thank you.